since we have a demo today, let's go ahead and get started with the technical update and then go straight into the demo.
Okay, here is community update 152. This is the last update for 2020. We have good progress to report. Today, we'll have a demo of Rholang 1.1 implementation. It is currently syntax to syntax translation, but there'll be a demo of that. And I believe Raphael is going to also demo the new spiffy RChain website, I believe. So let me go through the, there has been no change in the mainnet status or testnet. They're running the last finalized state version. The main part I wanted to report today is about progress on block merge. The team, basically, I've been talking about, and Greg has actually explained the math or formulas behind block merge last, I guess, couple of sessions ago. So the team has implemented that approach and is doing the refinements and resolving, any cases that are not falling within that resolution, within that approach. Give me 1 second. I'm admitting. Okay. So that work is continuing. We should have a version of a block merge release candidate within the next several days to maybe a week or so. So that's kind of where we are. There's still work to be done there in terms of testing, optimization, fixing the bugs, and adding any improvements, enhancements. I listed here some of the issues that if you go into this issues tab, there are a bunch there that are tagged as being needing to be resolved or going to be resolved as part of the block merge delivery, the 0.11 version. So that's part of the scope. And then there are the PRs that you can see in the main PR link that relate to the block merge activity that is going on. So that's overall good progress on the block merge, and the full team is working on it now. And they're focused on block merge alone and whatever is needed to make that happen. So that's the main part of that. And we'll do probably a couple of releases or more of that into the feature branch, and then we'll do a demo of that when it's available for a demo. Nothing new particularly to report on dependencies, though we are trying to improve the monitoring framework, because as we get to block merge and other things going forward, even with the Rholang 1.1, we want to be able to understand in sort of a more fine-grained manner where the resources are being consumed, whether it's CPU, memory, disk I/O. So we're trying to improve the methodology we have for looking at those. So first we need to update some dependencies, and then get to the latest versions of these, and then see what information we're getting, create new spans if necessary to get a more granular level of information. So that's one of the things that's important for us as we begin to look at what performance did we get and where can we improve things. So that's another piece that's going on. And the Rholang 1.1, like I said, the source-to-source translation is completed. There is a demo today. The tests are complete. Tests are added and they're passing, but the team has yet to review the code and approve. So there's quite a bit more work actually to be done with Rholang 1.1 in terms of getting it into deployed deployment on the mainnet. So it's currently not scheduled on any of the milestones yet, because we first want to complete the commitments made under the Mercury level and our Mercury version. So we're planning what all needs to be done, because to bring Rholang 1.1 on the main net means to having to change all the contracts we have into Rholang 1.1. But before we even do that, there's a lot of performance measurement and optimizations we need to do. Greg talked about a fuzzer to be able to run some tests with the Rholang 1.1, so we understand what the performance, where the performance issues might be, or what kind of a profile that presents us. So there's all that work that needs to be done. So we're not, and changing the system contracts is a very sensitive and significant piece of work, which will require a whole lot of testing of its own. So this is not something we're prioritizing getting onto the mainnet at this point in time. However, as much as possible, we will create the examples and possibly a test net or a test node that people can work with to experience the Rholang 1.1 syntax. So that's something we'll enable. And then there are things to be done from a user perspective or developer perspective, such as, for example, changing the visual code and IntelliJ pieces, the front-end IDE plugins that we have that need to be changed to Rholang 1.1. So there's a lot of work there. I just want people to be aware that there's not something that's going on the mainnet immediately or anything like that. It'll be, we'll tackle those. We'll first put a plan for these and prioritize them, and then tackle them after the Mercury feature release is complete. So that's where we are with that. And nothing new on the APIs. Yeah, I think that's primarily what I wanted to address today. Are there any questions or comments on what I said so far before we go into the demos? All right. A very happy New Year to everyone. Who wants to go first? Raphael, you want to go first, or Joe?
I can go first.
Okay, go ahead.
Good. So, hi everyone, I'm Joe. I did the Rholang 1.1 preliminary implementation. I have a brief demo prepared today. It's a fairly simple contract, but I find those are better for demos so that we don't get too caught up in other sort of complex aspects about the demonstration. So I'm going to assume that everyone here has a baseline familiarity with Rholang, which means you'll understand sort of at least the first thing that happens in this tiny program that I've written, which is that a name subtract is generated, and the name standard out is bound to the row IO standard out channel. So this is what allows us to do printing. I send a message to standard out, and it's printed to the console. I'm going to use this to demonstrate progress in the program that I've written. The first construct that's new is a let construct. There are two kinds of let constructs in Rholang 1.1, one that's sequential and one that's concurrent. I have the sequential one written here, but I can also describe the concurrent let construct. It functions largely similar to let constructs in other programming languages, with a couple of notable exceptions. Well, the first thing is I'll say that this is a sequential let construct. What that means is that each of these bindings are going to be processed in sequence. Meaning that first, and here the arrow notation is used instead of an equal sign, but it functions similarly. First, we're going to say that 2 is going to be bound to this variable a. And you notice I just got rid of the quotation mark. So it's not exactly that 2 is bound just to a variable a as itself. In let constructs, the values that we're binding are actually quoted when they're bound. So if we want to maintain a reference to A as it represents 2 and not to, say, at 2, which is a channel, then we'll have to pattern match on the A. And this allows us to retain a reference to A as a process and or value. If I decided instead to remove the quotation and I tried to use A here, then I would get an error from the compiler saying that I'm attempting to use a name in a process context. That's because we send processes in Rholang. And this is, as it is here, bound as a name. So with that clarified, this will first evaluate or bind 2 to A. It'll then bind 3 to B, and then bind 5 to C. And these are the basics of the sequential let construct in Rholang. The concurrent let construct has syntax this: ampersands. The concurrent let construct allows you to evaluate each of the expressions that are used for the bindings in parallel. So at present, this isn't going to be really handy because we don't have a lot of computationally, well, the expression language is limited in expressivity, ironically enough. But when the expression language is expanded to include things like, I don't know, well, like incredibly complex hash functions, or basically computationally expensive arithmetic, any extended computations that can be expressed in the expression language, then this concurrent let construct will become more valuable because it allows us to perform each of these bindings concurrently. For now, we can stick with the sequential let construct. Line 7, you'll notice here, is just standard stuff. So we're just going to print let and then the values that we bound. So we should see 2, 3 here, 2, 3, and 5 printed here. And in parallel, we're going to create 2 new unforgeable names, X and Y. And let's take this one line at a time. Rholang 1.1 has an upgraded send syntax. So whereas Rholang previously does not allow you to have a continuation after a send, Rholang 1.1 does. When I say continuation, I mean that the only kind of send constructs that Rholang as it stands allows are these. And in parallel, you'll typically do some sort of for comprehension, which means that we don't have a way currently to express sending something and then doing something else, say a process queue. Rholang 1.1 allows us to do that, and to express what we call the synchronous send, we use this syntax, which you call a bang whimper. So this is saying, first I'm going to send A on X, and I'm going to wait for confirmation that A was received on X before proceeding to the continuation, which is this expression. This is actually an important point. So now that we have ways to compose processes sequentially and concurrently, we need to be careful about, or we need to know sort of which of these constructs, sequential or concurrent composition, binds tighter. And in fact, sequential composition binds tighter. So this expression, and basically the easiest way to think about it is that a pipe will always be the top level syntax that breaks processes into pieces. So this pipe separates this process and this process. This process, as I said, sends on X, waits for a confirmation, and then prints standard out, so A received. And the process on the right does similarly with Y, B, and saying that B is received. So what this tells us is that both X and Y will send their respective values on the respective channels concurrently. If we wanted to impose that X is sent before Y, then we do something like this. So by adding the braces around this continuation after X, we impose that first X is, or first the send is executed, and then this entire continuation is executed. And since this continuation happens after the X, whereas the continuation of the X, then Y is going to necessarily be executed after the X produced. There's a complementarity to the Rholang 1.1 syntax. So to successfully use the synchronous send notation, which is bang whimper, each bang whimper needs to be paired with a whimper bang. So we're sending on one side, we're receiving on the other side. These are duals, so the syntax being backwards, it's sort of makes sense in an intuitive way if you think about it. But first, let's talk about the structural changes to the for comprehension. As you'll notice now, there are two different forms, like in the let construct above, two different ways that we can combine consumes. The semicolon, as you would expect, is a sequential combination. That means that everything that's on the left here is going to be executed, and then everything on the right is going to be executed. So this effectively is a simpler way to write nested for comprehensions. This is like writing a for at n coming in on x, whimper bang, and then putting all of this in a second for comprehension nested within the first. The second new piece of syntax is the ampersand. Ampersand is going to do what the semicolon did before. So this is going to enable us to do concurrent joins, meaning that we're going to wait on y for our result, and we're going to wait on something else for a result, which I'll explain here in a second. But the point is now that the semicolon no longer represents joins as we knew them. Now it represents sequential joins. And the ampersand now represents what we used to do with joins. So with that out of the way, let's talk about this new channel syntax. The first piece, as you heard me mention earlier, is whimper bang. This complements the bang whimper that we have in the same scope. This is going to say receive something on X and then send back to the sender that it was received. So if this were, for example, just an X, then this would never proceed because we're not indicating in source code that we want to indicate to the sender that the value was received. The same applies over here. We're indicating to y that we're going to send back to y once the value has been received, but this I included to demonstrate that you can, in fact, use these more complex source constructs like the whimper bang with joins. And it should be noted here that all of the previous pattern matching capabilities of Rholang are preserved. So we're used to being able to match against complex patterns that include remainder syntax, for example. So I could do something like this that would allow me to bind two arguments and then the rest of the arguments sent to a list Z. I can still do all of that. So the final piece of syntax that was added is this bang whimper source construct. And when I say source, I hope it's clear by now that I just mean like in the place of a channel. So we'd say that X is a simple source. X by itself is a simple source, just a channel, that the whimper bang is a complex source, and that the bang whimper is also a complex source construct. The complex source construct says that we first are going to send the arguments to the channel indicated in the source, and then wait for a response that's going to come back, and we're going to bind to 0. So this allows us to, it's a sort of shorthand for the more complex contract calls that we're used to making in Rholang. Instead of having to provide a return channel and a for comprehension on its own, I can simply do a bang whimper with 6 and 5 and get the return value returned by the contract directly. So so subtract here is a for comprehension that waits for, and this is important to notice, a return channel and 2 arguments. So the first thing to note here is that the return channel is going to be the return channel that's inserted, that's generated de facto when this subtract construct is compiled. So in order to indicate to the subtract source construct that we're returning our value and to bind it to 0, we're going to use return to return our value. So if this is a value we're returning, P minus Q will be bound to 0. The reason that the return channel needs to go in the front and not, say, at the back, as sometimes is the more idiomatic Rholang way to go, is to preserve pattern matching. So if for example, the implementation required that we do this, then we would no longer be able to use remainder syntax to bind lists of values, as I was mentioning earlier. So by setting the convention that the return channel is the first argument, whenever we use this bang whimper syntax as a source, we preserve the pattern matching capabilities. And so finally, after this contract and these two produce as execute, we should see a standard out produce a very complex way to do a simple arithmetic computation. And so I have the Rholang command line interface running here that I'm going to run just to demonstrate to you that it does what I have claimed that it does. So you'll see this is the printed version of the Rholang translation. This is what Rao meant when he said that it was a source-to-source translation, is everything you see here is implemented in terms of previously existing Rholang constructs. As you know, as a result, that means that the expressions that are printed are going to be far more complex than the expression that I have written above. So the first thing that we see, as expected, is that the let statement prints. The second thing that we see is that the A was received. This makes sense because we indicated here that these should be a sequential for comprehension. So I would expect that the value was received from X and then indicated to X, to this continuation, that it could proceed. The next thing that we're going to see is subtract execute. So that is down here, meaning that we're going to bind this value to O, which is 6 minus 5, so 1 we're going to bind to O. This can proceed in parallel, as I mentioned before, because we have this concurrent join here with this produce statement. And that's why we see that subtract is executed, and in fact, standard out prints the final result before we see that B was even received. And if anybody has any questions, I'd be happy to take them now.
So I'll give people a minute to marshal their questions, and if there are no questions, I want to make just a few comments. But you know, while they're marshaling their questions, thank you very much. It was an excellent demo, clear and concise, and illustrating the basic features.
Yeah, very nice, Joe. Thank you.
So any questions for Joe? All right, I just want to make a few comments. So first of all, if someone wanted to write the semantics of the Rholang 1.1, then with Rholang 1.0, they more or less had to write something akin to the generated code below. Do you mind just showing the, so you can see the Rholang 1.1, and you saw how big that was, and now look at how big the Rholang 1.0 is, and you'll see that this is a significant code compression. Smart contracts become a lot easier to read using Rholang 1.1, and the semantics are closer to the kind of thing that a programmer might expect from more mainstream language such as Scala or Haskell. There are some differences, but we don't have to dwell on that too much in this particular venue. The other point is that much of the generated code clearly identifies channels that will never have interesting transactional import. So the new channels that are created for the synchronization between the X bang whimper and the X whimper bang can be elided. That does not need to hit the blockchain. And because we have syntactic markers in the source code, we know that it can be elided, and we never ever have to hit the blockchain for a transaction, which means that we can significantly speed up the execution. Right? There's no need to record those COM events in a block. So that's a place for optimization that we will be implementing at a later date. Finally, very much to the point of the work that we have been doing with respect to Dazzle, the last invocation, the subtract. So you'll notice that what that does is that allows us to add an argument as a part of the listening. So the addition of that argument as a part of the listening on the subtract call is what allows us to add an argument, which is the Dazzle token, as a part of retrieving data that matches a particular pattern. So now we have an implementation of the essential feature, essential character of the smart contracting surface that allows us to quickly realize or implement the Dazzle APIs. So those are the three things that are enabled by this proof of concept. 1, code compression. 2, code optimization and speed up of execution. And 3, the implementation of the Dazzle API and other kinds of APIs that want to thread additional information through a listening request. Any questions about that?
So just to clarify with the Dazzle piece, it was the whimper part, whimper syntax.
Look at the subtract, what Joe's just highlighted.
Okay.
Right. So here, the way Joe is using it, he's making a call to the subtract method. So subtract one thing from another thing.
Mm-hmm.
And whatever the result is, that's going to be bound to the @o variable.
Okay.
All right. But it's not a requirement that be the only, subtract is not the only contract. So in particular, we can have the Dazzle smart contract or some Dazzle code right there, which will receive the Dazzle token and then go and do the retrieval of the data that will then be bound to the @o. And in particular, since @o is just one kind of pattern, you can put any kind of pattern there. So that gives you the basis for being able to retrieve, but only retrieving clean content if you've supplied enough Dazzle token. Does that make sense?
Yeah, that was helpful. Okay, I was going in the wrong way, so now I think I have a better understanding.
Sure.
So for the record, this subtract call would still work if this were a persistent consume, and we know that persistent consumes are equivalent to contracts.
Yep.
So this is, we can just as easily make this a contract here instead of a for. So that might clarify a little bit conceptually how the API would sort of meet.
Nice. Good little observation there. So thank you very much. That was very helpful. So hopefully people are seeing that we are making enormous progress towards our goals. And I was delighted to see the rate at which this was done. I appreciated all of the engagement on the spec during the implementation. So thanks very much.
No problem. I'll stop sharing.
Okie doke. So I have a little bit of a Christmas gift. It's not much, but as of this morning, I have signed an NDA with a little startup that is doing chip manufacturing of a new kind of chip. The company is called GSI. GSI is, it's no secret that they're manufacturing a chip that is beating out CPUs and GPUs. I know them because one of my colleagues, we've known each other for 20 years plus. And he worked with me on BizTalk at Microsoft. And then he moved on to Amazon and helped them with a number of different projects, but in particular, he's known for their drone delivery system. So he's quite a force to be reckoned with. So we will be looking at the possibility, and again, it may not be feasible, but we'll be looking at the possibility of a compiler from Rholang to their chip. So that we'll do some little feasibility studies to see, how effective it would be to go straight to the metal from Rholang to their instruction set. So that's some work that's underway, and I just wanted to let some folks know about that. Again, I can't really open the kimono about the technology because that's under NDA, but it is okay to talk about the fact that we're just doing some preliminary investigations as to whether there's a good fit there. Any questions about that?
Their main advantage seems to be in-place associative computing. Is that what they're?
Yeah. So there is a bit of a match between the way they're doing things and the way Rholang needs to operate. I mean, there's some differences, but there's a match. And so if there's enough of a match, then it's relatively straightforward to implement the kinds of semantics that we need on top of their chip. And then realize blazingly fast execution of Rholang smart contracts. Okay, then I guess Ian has been shepherding Raphael's changes to the website. So do you want to give us an update, Ian?
Sure. Okay. So I'm screen sharing a pull request that we just merged to the RChain co-op website, where Raphael and I believe a couple other people contributed to a very nice facelift for the site. So here's GitHub RChain RChain co-op if you want to look into it or make any corrections or contributions. And here's the live site with a new look and feel. Most of the content is the same, however. So I'll just take a quick run through the pages so you can see the new layout. That's the home tab, the platform. Very nice changes to ecosystem. And I'd say more work to be done. Especially I think with this hackathon page, which is mostly now links to some great resources. And let's see, the community page hasn't changed much. How to join the cooperative. The team. We have a couple editions where we have some updates to the bios to make. And that's about it. So back to you, Greg.
Thank you. Yeah, I think it looks lovely. It's really nice to see these kinds of updates. Keeping a website fresh is no small task, and it's an ongoing task. So I'm really grateful to Raphael and others for refreshing it.
Actually, Theo is on the call right now, and he had a hand in this as well. So thank you, Theo.
Oh, thank you, Theo. Yeah, exactly. Wonderful.
Yeah, sure.